Hey there, so today we're going to learn how to solve systems of equations using substitution. So we've already learned how to solve systems of equations using graphing. We're going to do an example showing or reminding us how to solve systems of equations by graphing first, and then we'll show you how to use substitution, so a second method. We have 3 total methods that we will use. We have graphing, substitution, and elimination. We're going to, already did graphing, we're going to do substitution today. So in this first example, we're going to remind ourselves how to solve equations using graphing. Remember, when you use graphing, you always want to turn your equations into slope-intercept form. Don't forget that's y equals mx plus b, so make sure you write that along with me above where it says graphing. All of these equations need to have y by itself or need to be in slope-intercept form. So for this equation, this first one, I'm going to get the x on the other side, so I'm going to subtract it. So I end up with y equals negative x plus 6. And then for my other equation, I'm going to use a different color. Try to do that on yours as well, just so you can keep your 2 equations separate, so you know which one is which. On this other equation, I have to get y by itself, so I'm going to subtract 2 on both sides. So I have x minus 2. Okay. For my red equation, you don't have to write this out every time. I'm just going to write it out so we remember. On my red equation, my slope is negative 1. My y-intercept is 6, and then on my blue equation, the equation that I'm putting in blue, my slope is 1, my y-intercept is negative 2. Okay, so for my red equation, let's graph that one first. My y-intercept is positive 6, so I'm going to go up to the positive 6. Please put a nice big dot on positive 6. And then my slope is negative 1, which means I go down 1, right 1, down 1, right 1, down 1, right 1, and put as many dots as you can. Okay, and then make sure you connect it all the way through. And let's put arrows at the end of it. Okay, so there's my red graph. Now let's check your blue graph. Your blue graph, your slope-intercept is negative 2. So on the y-axis, go to negative 2. And your slope is positive 1. So that means we're going to go up 1, right 1, up 1, right 1, kind of like a stair step. So up 1, right 1, up 1, right 1, up 1, right 1. There it crosses, up 1, right 1, up 1, right 1. Okay, you can go down 1, left 1, just to show that it keeps going and going. And then let's draw a line all the way through and arrows at the end. Okay, remember with graphing, your solution is just right here where both of these graphs intersect. So for this one, our solution is 4, 2. And your solutions to systems are always going to be ordered pairs. So 4, 2. Okay, so there's my solution to that system of equation. Though I'm going to show you how to do use substitution instead of graphing to do the same thing. So it's the exact same equation. Our steps to solve them, let's write them in right here. So your first step is going to be to solve for a variable if it's not already done for you. And it could be either of the variables. So we're going to solve for a variable. And then I have it typed out here too, if it's not already done for you. If it is already done for you, then you don't really have a step 1. My hint to you for when you're solving a variable is if one of them is not already solved for you, I want you to try to find a variable without a coefficient. And this will just make it so you have a little bit less work to do. So out of all the variables, you can solve for x or y of the first equation or x or y of the second equation. Try to find a variable that does not have a coefficient in front of it, just so you have a little less work to do. Okay, your second step is to substitute. So you're going to take that first equation or the equation that you just solved for a variable, and you're going to substitute it into the second equation. Okay, your third step is to solve that equation that you just substituted in. And then lastly, plug in to find the other variable. So I'm going to plug in to find other variable, which means if you just found x, you're going to take that x that you just figured out what it is, you're going to plug it into either of the equations. So as a note here, go and write use either equation. Doesn't matter which one you use. And you're going to figure out what y is. Or if you just solve for y, you're going to plug y back in to figure out what x is. All right, so let's take a look at the same example that we just did up here. We know the answer is right here, 4 comma 2, but I'm going to show you how you get it with substitution. Okay, so again, your first step, as we wrote right here, solve for a variable. Well, if you look at these equations, this first equation right here is not solved for a variable, meaning you don't have an x by itself and you also don't have a y by itself. So that first one is not solved for a variable, but this second equation is solved for a variable. It's solved for x. Okay, so we're going to use that second equation. That's already done for us. And I'm just going to rewrite that equation here under step 1 just to show which equation I'm using here. Okay, so I'm going to use the equation that is solved for x. It's got x equals y plus 2. That's the equation I'm going to use. Okay. All right, and then from there, it says to substitute it in. So if you want to number your equations 1 and 2, I'm just going to take x from this second equation, and I know x is y plus 2, so I'm going to take y plus 2 and plug it in for x of my first equation. Okay, so again, my first equation is x plus y equals 6. Okay, but my first equation is telling me that x, instead of x, I can just write y plus 2. So in place of x right here, I'm just going to put y plus 2 because my second equation is already solved for x for us. Okay, so in place of x right here, and I'll kind of color code this, in place of x right here, I'm just going to plug in y plus 2. Okay, so instead of x, I'm going to put y plus 2 and then bring everything else down. So plus y equals 6. Okay, now I just have to solve for y. So I have, let's see, we have 1y here, 1y here. So we have 2y plus 2 equals 6. Let's subtract 2 on both sides. We have 2y equals 4. Divide both sides by 2, and you get y equals 2. Okay, so what we did is we plugged in place of x in our first equation. We plugged in y plus 2 because our second equation was already solved for x for us. Okay, so in place of x in our first equation, we plugged in y plus 2. We put it right here. Combine your like terms, simplify it, and solve. We end up with y equals 2. So I know that my y coordinate is 2. Now you use your y coordinate to figure out your x coordinate. And this is where I said it doesn't matter which equation you use. So we know that y is 2. You could put the 2 right here, or you could put the 2 right here. Either way, it's going to give you the exact same answer. So it doesn't really matter which one you do. I will go ahead and just use the first one. But again, it doesn't matter which equation you use to solve for x. So again, I know that y is 2. And I'm just going to go and use that first equation. So I have x plus y equals 6. I know that this y right here is 2, so I'm going to put x plus 2 equals 6. Okay, if I have to solve this, subtract 2 on both sides, I know that x is 4. If you wanted to use the other equation, that's totally fine. So for this equation, my y is 2, so I would actually put the equation we're looking at is x equals y plus 2. Again, we know that y is 2, so in place of y, I'm going to put 2. So x equals 2 plus 2. Okay, I know 2 plus 2 is 4, so I get 4 this way as well. Again, notice in place of y, we're plugging in a 2. It does not matter which one. You do not have to do both of them. I would just choose one of the equations and plug in the variable you just figured out. In our case, we just figured out what y was. So plug that into either of the equations, and then you can get your x coordinate, which in this case is a 4. Okay, so final answer here, my ordered pair, and your solutions are always going to be ordered pairs. I have 4 comma 2, which is the exact same thing we just got right there. All right, so let's try another one. Okay, so let's take a look at number 2. And for example number 2, again, your step 1 is to solve for a variable if it's not already done for you. Well, if you look at your 2 equations, you have y equals 3, and you have 2x plus y equals 3. Well, you have to try to find one where the variable is already solved for you or where the variable is by itself. Well, in this first equation, the variable is already solved for us. We already have y solved. And again, you don't have to write this always for your step 1, but I'm just going to write down which equation I'm about to use. So I'm about to use that y equals 3. So I take my other equation, my 2x plus y equals 3, And what I'm doing is in place of y right here, I'm plugging in this. I'm plugging in 3 because I know that y equals 3. So use your other equation to know what to plug in. Okay, and I'm going to keep it in parentheses just to show you what I just did. I just took this y value right here and I plugged in a 3 because this up here told me that y equals 3. Okay, now we just have to solve for x. So I'm going to subtract 3 on both sides. I get 2x equals 0 because 3 minus 3 is 0, which if I divide 0 by 2, I still just get 0. Okay, so I know that the x coordinate is 0, and then usually I told you guys you can use whichever equation you want to figure out your other coordinate. So in this case, we already know x is 0, so now I need to figure out the y coordinate. Well, if I'm trying to plug in an x to be 0, I can't use this first equation because it doesn't have an x. So let's use our second equation here and let's plug in a 0 in place of x right here. Okay, so I'm going to write, I'll do this in different color. So my equation I'm using is 2x plus y equals 3. In place of x, I'm plugging a 0 because I know that x has to be 0. Okay, 2 times 0 is 0, so y equals 3. Okay, which honestly, since they tell you that basically what this is saying right here is it's saying that y has to be 3. So pretty much once you find what x is, you already know what y is because they already told it to you. But if you want to use an equation to plug it in and figure it out, you can also just plug it in. Okay, so my final answer here, my ordered pair would be 0, 3. Okay, and remember solutions are always ordered pairs. At least in these examples, we're always going to have one solution, one ordered pair for our solution. All right, I'm going to help you get this one started, and then I'll see if you guys can finish this one up by yourself. Okay, so for example 3, step 1 is to solve for a variable. Well, if you look at these two equations right here, this one does not have a variable by itself. This one does also not have a variable by itself. So my little hint for you that I put right here, find a variable without a coefficient. So see if you can find a variable here that does not have a number in front of it that's bigger than 1 or smaller than 1. So if you look, this has a -2 in front of it, this has a 4, this has a 2. See if there's a variable that only has a 1 in front of it, which would be this one. So I would use y here, and in this first equation, I would solve it for y and then use that for my step number 1. Okay, so I'm going to use that first equation. I'm going to solve it for y. Well, if I'm trying to solve this equation for y, I need to get this -2x on the other side. So I'm going to add 2x on both sides. So my equation would be y equals 2x minus 1. Okay. All right, now that I know what I'm using, so I'm using y equals 2x minus 1. That's from my first equation. So I'm going to use my second equation. I always like to rewrite it. It's just the 4x plus 2y equals 14. All right, so all I do is my step 1, I solve for a variable, done. Step 2, substitute and solve. So what that means is I take the y that I just solved for and I plug it in for y of that other equation. So I will plug it in for you and then I'll have you guys finish it up by yourself. So your 4x stays the same because I solved for y. So in place, again, in place of the y right here, I want to plug in all of this, the 2x minus 1. Okay, so I have 4x plus, here's my 2, keep it in parentheses, 2x minus 1 equals 14. Okay, all right, from here we have to solve for x. Okay, my hint for you as you get started here is I need you to distribute your 2, then combine like terms, and then simplify and solve for x. Go ahead and figure out what is x in this one. Okay, when you solve for x, you have 4x plus 2 times 2 is 4, so that's 4x. 2 times 1 is 2, so there's minus 2 equals 14. Let's combine your 4x and 4x, so we now have 8x. Minus 2 equals 14. Add 2 on both sides. You have 8x equals 16. So then x has to be 2. Okay, so on your ordered pair here, my x is 2. So I know this ordered pair here, my x is going to be 2. All right, so now, again, using either of the equations, and just a little hint, I would use your equations that you start with instead of the equations you solve for, just in case you accidentally made a mistake, but it doesn't really matter. If we know that x is 2, you could plug in for, you could plug 2 in here, you could plug 2 in here, you could plug 2 in there. It doesn't really matter, whichever you want to plug 2 in for. I'll go ahead and use just this second equation, but you can use whichever one you want to. Go ahead and use either of the equations to plug in our x equals 2 and figure out what is y. Okay, so as you're solving for y here, I will solve for y just right next to this in a different color. I'm going to use this second equation, the 4x plus 2y equals 14. You can use whichever equation you want to. It'll give you the same answer. So I know that x is 2. So in place of x, I'm going to put 2 plus 2y equals 14. This is 8 plus 2y is 14. 14 minus 8 will give you 6. So then y has to be 3. Okay, and if you want to just double check, it's no harm in just double checking. Maybe pick another equation and see if you also get 3 for your other equation. Like you could pick this first one. And in place of x, I'm putting a 2. So what that would mean is I am doing negative 2 times 2 plus y equals negative 1. Well, if I solve that, hopefully I get 3. Let's see. This is negative 4 plus y equals negative 1. I'm going to add 4 to negative 1, and that also gives me 3. So notice you'll get 3 no matter which way you do it. You do not have to do more than one way, but just know whichever way you choose, you will still get 3. Okay. All right, so I'm going to have you guys do one more, and then the rest of these examples, I will have them posted on Canvas. So if you would like to just try them on your own and then look back, instead of having them be part of the video, you can always do this on your own. But let's take a look at this first example. And well, actually, for all of these ones, how about you guys can just try these on your own? These first 3 examples are the examples that we'll use in the video just for practice. And these 4, actually 5 examples that you have, you can just finish them on your own if you would like to. And then that way you have more practice, and then you can check your answers with the answer key that is on Canvas. All right, so always feel free to look back and try any of these that you want to. Actually, let's go ahead and do this first example, just because in this example, you don't have all of these like steps leading up to how to do it. So I'm changing my mind. Let's go ahead and do this one. Okay, all right, so for this first example that you see here, notice you don't really have any leading steps, so you got to kind of think of your steps on your own. Step 1, check to see if there's any of these that are solved for a variable. If not, solve for it. Also notice in this first example, I do need you to change that first equation to make it say 3y plus 2x equals 19 instead of the 3x plus 2y equals 19. So please fix this. All right, and then again, your first step is to solve for a variable. My hint to you is to try to find a variable that has 1 as a coefficient. That way you don't have any dividing to do, okay? So I'm actually going to solve for this one. And I guess instead of saying no coefficient, I'm going to say as 1 for a coefficient. So find a variable with 1 as a coefficient. Let's do that. 1 as a coefficient. So go ahead and fix that one. I don't mean without a coefficient. Well, I mean, it doesn't really, you can't really see the coefficient there, but I want you to find a variable that has 1 as a coefficient, okay? All right, so our example here, the variable that has 1 as a coefficient would be this one. So I'm going to get y by itself. In order to get y by itself, I need to take this negative 6x and put it on the other side. So I'm going to have y equals 6x minus 7. All right, go ahead and do your first step of taking this that we solved for y, the 6x minus 7, and plug it in for y right there. So go ahead and plug it in, and so once you do that, go ahead and solve for x. What do you get for x in this one? All right, so when you solve for x, let's show all of the work to get x. So the equation I'm using is the 3y plus 2x equals 19. Okay, in place of y, In place of y right here, I'm using 6x minus 7. So I have 3 parentheses, 6x minus 7 plus 2x equals 19. I need to distribute. So I have 18x minus 21 plus 2x equals 19. Combine your like terms. So you have 20x minus 21 equals 19. Add 21 on both sides. Divide by 20. And 40 divided by 20 gives us 2. All right, so I know that x equals 2. Now, using this or this, figure out what is y. Okay, I'm going to go and use that second equation because in that second equation, the y is already by itself. So I'm going to use that second equation. I know that x is 2, so this negative 6x plus y equals negative 7. I know that the x is 2, so in place of x, I'm going to put 2 plus y equals negative 7. This is a negative 12 plus y equals negative 7. Okay, and then add 12. And you'll get that y is 5. And again, you should be able to get that for either of the equations. So I could also use that other equation, the 3y plus 2x. Let's try that one. So 3y plus 2x equals 19. I'm pretty sure x is 2. Let's double check. And let's make sure we get the same y. So this would be 3y plus 4 equals 19. Subtract 4 on both sides. 19 minus 4 gives you 15. 15 divided by 3 gives you 5. So notice we got y equals 5 both times using different equations, but you still have the same y value. Okay, and then remember, your final answer, do not put x equals 2, y equals 5. I need an ordered pair. So the x coordinate of the ordered pair is 2. The y coordinate of the ordered pair is 5. All right, now we're all done. So again, if you want to try these last 4 examples that are here, feel free to try them. And I will post those notes on Canvas. That way you can go back and check them if you need any extra practice. I would also keep these notes handy as you go to do your assignment tonight. That way you have the notes ready to go and they're all kind of like broken up for you just to show how we got the x's, how we got the y's, and we did a bunch of different ways to solve them as well. So either solving for the x or solving for the y. So we have a bunch of different ways that we solve these. So please keep your notes handy, ask questions or shoot me a Canvas message if you're stuck on any of these, and let me know if you have any questions.